Hey all, welcome back. Spark Concepts were kind enough to send me one of their CNC xPRO V5 controllers to do an installation and configuration video on. I'm going to be doing the install on my Queen Bee Pro CNC from Bulkman 3D. However, these steps will work on most 3-axis CNC machines. Start by locating your 4-pin motor connectors and remove them from the controller. If you don't know your coil pairs, hold any two wires together and turn the stepper motor by hand. If you feel resistance, then this is a pair. Placing the first pair into A positive and A negative, then the remaining pair into B positive and B negative. For me, this works out to be red and green in A positive and A negative, and blue and yellow in B positive and B negative. As you can see here, I like to use ferrules on my connections to keep them strong and consistent. I'll place a link to the kit I use below. Pro tip here, write the axis letter on the connector so you know which is which when you're all done. Once these are all connected and you have tested each cable, go ahead and plug the connector into the corresponding axis. Now we can move over to our end stop switches. These are the 3-pin connectors below the stepper motor connectors. Again, write the axis letter on the underside of the connector. Connect the wires going to your end stop switches to the 2 outer terminals on each connector. Once these are done, make sure you test each cable again, and then connect them to the corresponding axis. Great, moving over to our power supply. I have made a cable here that has ferrules on one end and spade terminal connectors on the other. Check the orientation of your connector and make sure you wire the negative wire to the negative pin and the positive wire to the 24-volt pin. Check this twice, as reversing this can fry your controller. Now moving to the other end of this cable, again double checking that you wire the negative and positive to the correct locations on your specific power supply. Moving on, wire your emergency stop switch, and on the controller side, go ahead and connect the wires to the emergency stop switch connector, which is a 2-pin connector on the power supply side of the controller. For those of you that have a Hongyang VFD, let's wire this up so we can control it directly from the controller. First you need a 2-wire cable. Connect the wire that you will use as the positive wire to the A pin and the negative to the B pin on the RS485 port. Moving over to the VFD, find the RS negative and the RS positive pins, and wire the positive wire from the A pin to the RS positive pin, and the negative, which is B, to the RS negative pin. You can now power up the controller, and let's get ready to configure it. The first thing we need to do on our computer is install the drivers for the controller. I have put a link in the description below. Extract the zip file and find the install file cp210x vcp installer x64 if your computer is a 64-bit, if not, use the x86 version. Run this and follow the steps. Once this is installed, you can connect the USB cable to your computer. Now for the software. There are many different options as this is a GRBL controller. I'm going to go with the tried and tested CNC JS. Find the link in the description below, run the file and let it install. Now start the program. It should detect the port. Mine is COM3, but yours may vary. If you don't see this, make sure that the controller is powered up and the USB cable is connected. Now click Open. Once it is connected, you will see the configuration and the status print out in the console on the left. Now that the machine is connected, we can start with setting it up. First off, I'm going to jog my machine as I know the settings that ship with the controller are a good starting point. I will start by resetting the controller and bringing it out of lock. Now with the distance set at 10 mm, I'll move Y in the positive direction. The machine should move away from us. Okay, the machine moved towards us, so we need to reverse this axis. While we're here, let's test the x-axis in the positive direction. We expect to see the machine move to the right. Okay, the machine moved to the left, so we'll also need to reverse our x-axis. Lastly, we can test our z-axis. Let's try and move this in a negative direction. We expect to see this move down. Okay, so it went down, so we do not need to reverse our z-axis. Let's expand our console. Here we can enter commands to change the settings on our controller. To get a reference of all the commands available, you can type $CMD. To reverse the axis, we are simply going to type $stepper/dir_invert equals and the axis we want to invert, so for me that was Y and X. Then enter. If you're like me and like to have your stepper motors powered all the time to stop the axis from being moved accidentally, like during a tool change, type the following: $stepper/idle time equals 255. Now let's minimize the terminal. Reset the machine and cycle through each axis to make sure they are now going in the correct direction. Starting with Y, onto X, and Z again. Okay, everything is fine there. Back over to the console, let's go through some other settings. To see the settings for a particular axis, you can type $ and the axis letter followed by a / and enter. For my machine, I want to run 1/16 microstepping, so $x/microsteps equals 16. Now I need a steps per millimeter of 400. So $x/steps per mm equals 400 and enter. We can repeat this for all other axes as they are the same on my machine. Now we can set our max rate, which is how fast the axis can move. I typically run my max rate at 4,000 millimeters a minute. So for this, $x/max rate equals 4,000, enter. And then repeat for the other two axes. Once this is done, you can set your acceleration, which is how fast we can get up to the max rate. I run my machine at 300, so $x/acceleration equals 300. And repeat for the remaining two axes. Now let's reset the machine and minimize the console. Now press Y positive. You can see the machine is now moving much faster and is accelerating faster also. It's now time to configure our homing and limits. Expand the console again and let's enable our homing first. For this, type $homing/enable equals on and enter. Now reset the machine. We are now going to test that our end stops are responding before attempting to home the machine. If you type ? and enter, you'll get a report back from the machine. If an end stop is depressed or the emergency stop is depressed, you will see the switch in this report. Here you can see no switches are pressed. Now when I press the Z and type $ again, you can see that the PN:Z is pressed. When I release ? again and nothing. Now let's do the same test on the X. PN:X and released. Good. And lastly, the same on the Y. PN:Y, okay, and released again, okay. Let's minimize the console and go ahead and test our emergency stop switch before we try to home this machine. As soon as we activate it, we should get an alert. Okay, good. Reset your e-stop and come out of unlock. Now, try and home the machine. Have your hand ready on the emergency stop. Okay, so as the axis is fine, but our X and Y are both moving in the wrong direction. So let's use our emergency stop. Back over to our console, however we won't expand it this time. Type $homing/ and enter. Let's check what settings are currently in place. Okay, here we can see that $homing/ dir_invert is set for both X and Y. Let's remove these by typing $home/ dir_invert equals and enter. Now reset the machine and with your hand ready on the emergency stop again, try homing. Okay, great, things are moving in the correct direction. But now you will see the axis doesn't quite get to the end stop and then it halts. This is because we haven't configured our machine size yet. So as a safety, the machine will stop after it reaches what should be the maximum of the machine. Press home again from this location and the machine should home correctly. Now that the machine is homed, we can work out our maximum settings for each axis. Jog the machine to the absolute furthest you can go in the X direction without crashing the machine. For me, this works out to roughly 742 millimeters. In the console again, type $x/max travel equals and the value that you get with your machine. So for me, 742 and enter. Now repeat the same steps for your y-axis. And repeat the steps in the console. $y/max travel equals and the number for your machine. For me, 772 and enter. Now reset the machine and try homing again. If you're running high current stepper motors, you can adjust the current of the stepper drivers in the xPRO. To do this, in the console, type $x/current/run equals and your calculated value. To work this out, you need to know the max current your steppers are rated for, and then multiply that by 0.707. I run my steppers at 3.5 amps, so this equates to 2.470. Repeat this command for each axis. Now, after resetting, test that we still have good movement. If at any point you notice your stepper drive is running hot, you will want to make sure that you lower this current. Moving on, if you have a Hunyang VFD and wired it up following the steps before, we can now configure the controller to communicate with it. Start by typing in the console $spindle/type equals Hunyang, then enter. The controller will immediately start looking for a connection on the RS485 port. Let's go ahead and power up the VFD now. Okay, good, we see the connection in the console now. Let's set our max and min speeds for the spindle. For this, $G code /max S equals 2400. Enter. And $G code /min S equals 8000. Let's test our spindle. I'll bring it back into view, and now scrolling down on the right hand side to the spindle section, I can set my RPM to 8000 and click M3 to start. Perfect, and now M5 to stop. Excellent. Now is also a good time to test your emergency stop again. Let's make sure that it's also stopping the spindle when we trigger it. M3. Okay, good. Your machine is now ready to go. I always run a job in the air before testing out a new machine. This is a good way to see if there are any issues before they become big issues. So let's load up a cam clamp and run it in the air. we can set our work home and start the job. Looks good to me. Stay tuned for more videos on the xPRO V5 controller, and thanks again to Spark Concepts for supplying me with this controller. Also, please like and subscribe if you can, as it really helps me out.